In the long river of human civilization, there have always been ambitions that dared to challenge the most severe laws of nature. At this very moment, beneath the seemingly tranquil blue surface of China's Jiaozhou Bay, an unprecedented dialogue with the Earth's core is silently unfolding. This is not a plot from a science fiction novel, but an engineering reality in the making. Here, Chinese engineers are constructing a super project that will redefine the impossible, the Jiaozhou Bay Second Subsea Tunnel. When it is completed in 2027, its total length of 17.48 kilometers, with a main tunnel of 15.84 kilometers, will surpass Norway's Reifuk Tunnel, 14.4 km, to claim the title of the world's longest subsea road tunnel. But this is more than just a triumph of length. Its maximum depth reaches 115 meters below sea level, equivalent to sinking a nearly 40-story skyscraper to the seabed. At such depths, every square centimeter of rock endures an immense water pressure of over 11 kilograms, a terrifying force capable of crushing steel in an instant, where the slightest error could escalate into a catastrophe. The sheer scale of this project would astound even the builders of the ancient Egyptian pyramids. The total volume of earth and rock to be excavated is estimated to exceed 8 million cubic meters, enough to fill 3 of Egypt's Great Pyramid of Khufu. The complexity of the geological challenges it faces has led even international consultants who worked on the English Channel Tunnel to declare them unprecedented. Therefore, this is not merely a story about building a tunnel. It is a story of how a city is suturing the lifelines for its own future, and a story of how human ingenuity is locked in a high-stakes game with the planet's most ancient, hardest rocks and its most unpredictable fault zones. To understand the necessity of this project, we must turn our focus to its protagonist, Qingdao. Qingdao, a city hailed as the Switzerland of the East, has a destiny inextricably linked to Jiaozhou Bay. This bay, spanning approximately 390 square kilometers, embraces the old urban districts of Xinan and Shaibai and the West Coast new area like an open arm. For the past century, however, this gentle embrace has been a formidable natural barrier. In the era before any cross-sea passage, the only way to get from the old city to Qingdao was a bumpy ferry ride that consumed over an hour. Locals used a vivid phrase to describe this separation: Qingwang Bu Jai, a term meaning the green Qingdao and yellow Qingdao do not connect, which also idiomatically means a gap in supply. This was not just a geographical divide, but an economic and psychological estrangement. The opening of the Jiaozhou Bay Bridge and the first subsea tunnel in 2011 was a milestone in Qingdao's urban development. It dramatically shortened the cross-bay commute to just a few minutes, making Qingwang Bu Jai a relic of the past overnight. The West Coast new area, with its vast land and policy advantages, rose rapidly, becoming home to Qingdao's free trade zone, economic development area, and port hub. Even the iconic Qingdao International Beer Festival moved its main venue there. However, the pace of development exceeded all expectations. By the early 2020s, the daily traffic on the Jiaozhou Bay crossing had surged to nearly 200,000 vehicles, with unbearable congestion during holiday peaks. The passage, once hailed as a miracle, quickly transformed from an artery into a thrombosis, becoming the biggest bottleneck hindering Qingdao's ambition to become a world-class Bay Area city. More importantly, both the bridge and the first tunnel are vulnerable to extreme weather, failing to provide true, all-weather access. For a city whose economy is centered on the ocean, and which boasts the world's fourth-largest port, having a lifeline that can defy storms and remain uninterrupted is an absolute necessity for its future. Thus, the Jiaozhou Bay Second Subsea Tunnel was born. It is no longer just a supplement to the first crossing, but a strategic move that will define Qingdao's urban landscape for the next century. Its mission is to completely suture the two shores of Jiaozhou Bay. If the city's demand is the driving force of the project, then the desperately complex geological conditions at the bottom of Jiaozhou Bay are the ultimate examiner that the engineers must face. Hidden beneath this seabed is a labyrinth forged by hundreds of millions of years of geological movement, with a complexity rarely seen in the history of global tunnel engineering. The tunnel's path must traverse two starkly different geological units. The western section is dominated by hard, stable Laotian system granite, its extreme hardness posing a severe test for excavation equipment. The eastern section, however, consists of soft, fragmented sedimentary rock and sand layers, which are saturated with water and extremely prone to collapse and water inrush during excavation. This is like asking a single knife to be able to both cut the hardest diamond and delicately carve the softest tofu. The construction difficulty is immense. Yet the real nightmare is not the rock itself, but the 22 fault fracture zones of varying sizes lurking within. These are the scars left by crustal movement, where the rock is utterly shattered, like tofu dregs, and forms natural conduits connected to the seawater above and groundwater below. Among these, the most daunting are the massive F1 and F22 fault zones that lie across the tunnel's path, especially the Qingdao fault, which is over 200 meters at its widest point. It acts as a great geological chasm, separating the hard and soft strata. To cross it at a depth of 115 meters under the sea is akin to performing delicate surgery directly beneath a suspended reservoir. Any misjudgment could allow high-pressure seawater and mud to pour into the tunnel with thunderous force, causing an irreversible catastrophe. This is no longer just an engineering problem. It is a game of death against the forces of nature, with an outcome of only 0 or 1. Faced with such a treacherous geological, natural barrier, traditional construction methods proved inadequate. Immersed tube method, prefabricating tunnel sections and sinking them to the seabed, as was done for the Hong Kong-Zhuhai-Macao Bridge. However, Jiaozhou Bay's busy shipping lanes and the massive environmental impact of deep dredging on the seabed led to this option being rejected. Single TBM tunnel boring machine method, using one giant TBM to dig from one end to the other. In strata with an ultra-large diameter of over 15 meters, mixed hard and soft rock and dense fault zones, the TBM would be at high risk of getting stuck, damaged, or even triggering a geological disaster. The risk was assessed as extremely high. Ultimately, Chinese engineers proposed a creative, tailor-made hybrid solution, a dual-mode drive combining the drill and blast method and the TBM method. This was like equipping this subterranean surgery with two sets of top-tier surgical knives that, despite their different styles, could work together seamlessly. The drill and blast method, a ballet on rock. In the hard granite zone, what unfolds is a ballet on rock that combines power and beauty. The drill and blast method, while sounding crude, is in fact incredibly precise. Precision drilling. Intelligent drilling rigs extend their robotic arms to drill hundreds of blast holes, several meters deep, into the rock face with millimeter-level accuracy. The distribution, angle, and depth of these holes are all calculated by computers to determine how the explosive energy will be released. Digital blasting. Explosives are not packed randomly, but use digital electronic detonators. This means each detonator's firing time can be individually programmed with a delay of just 1/1000th of a second. Through this sequential control, the blast waves act like a precise surgical knife, peeling the rock away along a predetermined contour rather than crudely shattering it. This ensures a smooth tunnel profile while minimizing disturbance to the surrounding rock mass. Threading the needle. When crossing fault zones, the engineers display a skill akin to threading a needle. They conduct advanced geological prediction, using radar and drilling to probe the geological conditions for dozens of meters ahead, much like giving the Earth a CT scan. Once a fractured zone is detected, they immediately perform advanced pre-grouting, injecting special cement slurry under high pressure into the shattered rock mass. This solidifies it into a sturdy, artificial rock, creating a safe, protective shell before the next excavation step. It is through this cautious, step-by-step approach that they are able to steadily chew through the most dangerous Qingdao fault at a rate of 2-3 meters per day. The TBM method, the steel behemoth. As the tunnel enters the soft strata of the eastern side, the stage is handed over to the true steel behemoth, the tunnel boring machine, TBM. The TBMs custom-built for this project have a cutter head diameter exceeding 15 meters, equivalent to a 5-story building, making them true giants. Devouring and building, its massive cutter head rotates, chewing through the mud and rock ahead with unprecedented force. The excavated material is transported to the rear via a screw conveyor and then pumped out of the tunnel through pipes. Simultaneously, robotic arms inside the TBM precisely grab precast concrete segments, each weighing several tons, and quickly assemble them into a ring, forming the permanent tunnel lining. The entire process integrates excavation, spoil removal, and lining, operating like an automated factory moving underground. An undersea U-turn. To enable simultaneous excavation from both east and west, the two giant TBMs had to be launched from two enormous vertical shafts in the middle of the tunnel. This meant these behemoths, weighing thousands of tons, had to be disassembled, lowered into shafts dozens of meters deep, and then reassembled. This process itself was a world-class engineering challenge. The heart of the project, the central interchange hubs. Perhaps the most breathtaking aspect of this project is not the tunnel itself, but the construction of two enormous mid-sea interchange and conversion spaces in the central undersea area. These are not simple junctions, but complex undersea hubs. Imagine, deep beneath the sea, a massive hollow structure equivalent in height to a 30-story building. It not only serves as the meeting point connecting the two main tunnels and a service tunnel, but also as the base for launching and receiving the TBMs. Even more creative is the ventilation design. Traditional extra-long tunnels require the construction of tall ventilation towers in the sea, which are unsightly and obstruct shipping. The Jiaozhou Bay second tunnel cleverly utilizes the central service tunnel as a conduit for fresh air. Fans on land pump fresh air into the service tunnel, which is then evenly distributed into the traffic tunnels through cross passages connecting the service and main tunnels. This ingeniously divides in two the nearly 16-kilometer ventilation distance, solving a world-class ventilation challenge while perfectly preserving the marine environment and skyline of Jiaozhou Bay. Conclusion: the legacy of humble grandeur. By 2027, when the Jiaozhou Bay second subsea tunnel officially opens to traffic, the hundreds of thousands of people who pass through it daily will likely only experience a few minutes of smooth and rapid transit. They will not see the heart-stopping drama that once unfolded deep beneath the sea, nor will they be able to touch the sweat and wisdom left behind by the engineers who toiled in the dark for thousands of days and nights. This, perhaps, is the highest realm of a super project. To be born of the most magnificent vision, yet to be integrated into daily life in the most humble way. It does not seek to be a dazzling, iconic landmark, but chooses to remain hidden deep beneath the sea, dedicating its glory to the city's unimpeded flow and returning tranquility to the myriad life forms on the surface of the bay.